Good morning, my dear students. Last session, we have discussed Eddy's theorem uh, in a full-fledged manner. This session, we will discuss about some of the geometries for the arch that we employ practically. For example, circular geometry may be opted for the construction of the arch, or maybe parabolic. Likewise, different geometry may be adopted for the arches to construct. Uh, why these properties are required? That may be the question. So, if you want to analyze the arch, you need the geometry uh, uh, in terms of, for example, in this case, let's see. See this portion is the arch portion, and the remaining portion is the completed portion for drawing a circle. This being a part of circle, the arch portion is being part of the circle. The remaining portion of the circle is being completed. So the actual arch here is ACB is the arch portion, and D is a point on the arch, chosen point. Then the radius of the arch is capital R, and the rise of the arch is H. Rise in the sense the vertical distance from the line joining of the springing points to the crown is nothing but the rise value. So H is a rise, and L is the span, AB is the span of the arch, and the Cartesian coordinates, x coordinate and y coordinate of the point selected on the arch, and the theta, the angle subtended by the point uh, selected on the arch at the center of the circle is theta. This is what is theta means. With respect to vertical, the angle made by the line joining center of the arch and the point selected on the arch. The subtending angle is theta. Now the properties, different properties, or the projections, you can say. The radius, if you project this radial line onto the horizontal line, you get r sine theta. Then if you project this line onto this vertical projection, will give you r cos theta value. So this is the hypotenuse being r. The opposite side is r sine theta, and the adjacent side of the triangle is r cos theta. So these are the properties which are required for working for the internal forces of the arch. You need the geometry of the arch, wherein you need to relate these Cartesian coordinates to the polar coordinates r and theta. This is the purpose of knowing these geometric properties. Okay, so now let's see what are all the geometric properties that you need to know to take up the analysis of the arch. In the sense, analysis of the arch means finding internal forces developed in the arch. So to do that, you need the geometry, the properties of geometry that you apply for the arch. For example, if the arch constructed is a circular one, then this is a relation that is possible for a circle. So what does it mean? Right, this line is being the chord. If you treat this as a circle and this is a chord, so this is a diametric line passing through the center of the circle. So if you see these two lines, there exists a relation between these two lines, that is this one. So the of product of the distances of the portions bisected by the diameter line is equal to, that means this is L by 2, this is L by 2. So the diameter line is bisecting this chord, so making into two equal parts. This is L by 2, total span is L, and this is also L by 2. The product of these two portions is equal to the product of the portions that the diameter line is divided by the chord. Chord also makes the diameter line into two parts which are not equal anyhow. So this portion is h, the remaining portion is 2r minus h. Total diameter line being 2r, that is 2r minus h. So this is the relation that exists between from mathematics, the relation between the chord and the diameter line. So from this relation, by rearranging, you see L square by 4, h comes to the denominator. So L square by 4, h is equal to 2r minus h. So writing for 2r, which is equal to h goes to the left. So h plus L square by 4h. So it goes to the left hand side. So what we need is the radius of this circle formed by this circular arch. So this you don't know because the given properties of the arch is only span is L, rise is h, and the point that you have chosen, the coordinates x and y coordinates may be known to you, that's all. You don't know the r and theta values. So that is where this circular geometry will help you to find out those properties. So you want to find out radius, use this relation. This h means rise value, L is the span of the arch, which are a given data which are known to you in the arch. So r is equal to h by 2 plus L square by 8h is the relation between radius of the circular arch and the rise and span of the arch. Right, going for the next slide. So here, as I said, you need to relate the Cartesian coordinates to polar coordinates, where in circular geometry is you feel better if you work with polar coordinates. So pointing to the earlier diagram, how do you write relation between x and L, H, R, all that? So looking at this x, which is L by 2 minus R sine theta, how we are able to write this? So this is the x value. So from here to here it is L by 2. So L by 2 minus this value, nothing but the projection of R that we discussed earlier, R sine theta. So L by 2 minus R sine theta is equal to x. I think it's clear. So this is L by 2, total span of the arch is L. So this is L by 2 minus r sine theta will give you x value. Right. Going for next relation y, that means ordinate of the point chosen on the arch. So y is equal to what is written here is r cos theta minus r minus h. So how we are able to write that from the geometry? So we need this value y. So if you can see that this total distance from the this point to this point is r cos theta, the vertical projection of the radial line. So this is r cos theta. So from this, if you are able to, what we want is this one. So if you remove this, then we will get this portion. So total is r cos theta. Remove this portion. What is this portion? So from again, this radius is center, the point on the circle, center of circle, point on the circle is nothing but radius minus rise will give you this portion r minus h. So now if you want to get this, let me make it clear. So we want this portion. So from this portion you need to deduct this portion. So this must be eliminated. So from total, this is r cos theta, eliminate this one, which is r minus h, will give you the y value. That is what is done in the next slide. So let me erase this one. Right. Okay, so that is what is written here. Y is r cos theta minus r minus h. That is the one which we have discussed. R cos theta minus r minus h. So this is how the circular geometry can be uh, uh, calculated. Similarly, that is simple rearrangement here. So minus of minus plus h, and r if you can bring it out. So minus r if you take it out, it will be 1 minus cos theta. So this is what is y is rewritten here. That's all. So this is about circular geometry of the arch. Now let's go to parabolic arch. So if the shape of the arch constructed is parabolic, how you what is the governing equation? How do you relate the quantities of now x coordinate and y coordinate with the properties of the arch, like span and rise likewise? So there are two options here for the arch parabola. So you can choose one of the abutment, that means springing point, as origin means 0 comma 0, or it can be crown point 0 comma 0. So first let us see what is the governing equation of geometry. If you take a springing point as 0 comma 0 as origin, so this is a governing equation that satisfies this arch geometry. So y is equal to 4hx by L square multiplied by L minus x. Now let us see. This is a well-known equation where you have undergone mathematics courses, right? if you take the origin at crown 0 comma 0, what will be the governing equation? So this is a general parabolic equation where the crown point is the origin. So by substituting the known point on this arch, we will be able to evaluate this constant. A is a constant. Okay, so what is a known point on this arch is either A or B if it is 0 comma 0. So what we take, this is L by 2, this is H. So x coordinate of A from C is L by 2 and y coordinate of A from C is H. So that is taken here. So L by 2 and H are x and y coordinates of this point when this is 0 comma 0. Maybe you can uh, you may doubt that why not this is a negative value, because this 0 comma 0 you take positive coordinates towards right hand side. This is all depending on you, so I choose a positive this side to the left of C. So this all depends on the user. So x is L by 2, y is h, and one more clarification is even if you write x is minus, it's going to be squared and it's going to become plus anyhow, right? So if you substitute these values into this equation, you get a is equal to L square by 4h. That if you substitute into this equation, we get y is equal to 4h x square by L square. This is the governing equation of an arch having 0 comma 0 at crown. Okay, so these are the simple geometric properties for arches. If you can construct in circular geometry, or what is the geometric properties required for solving an arch geometry, and even if it is constructed in parabolic, then what could be the geometric properties, right? Going for the case where springing points are not at same level. Why this case arises? Uh, Say for example, you are constructing a bridge uh, uh, where this is a bridge, okay, and wherein the river location, river flows like this, where some hillock on this side and another hillock on this side, where the two banks of the river are at different level, maybe, or to rest your foundation abutments, to rest your foundation abutments, the good soil may not be available at the same level. Such situations arises where springing points are not at same level. So springing point here is different level when compared to this. So if this is a case, how do we uh, get the geometry of this arch? So this is again by picking 0 comma 0 because you see the portion AC properties, that means span and rise, are different from the portion BC, span and rise. Okay, rise of this portion is this one and span is this much. So these two are two different parabolas that you need to first identify, because this span and rise is different. the span and the rise is different. So if the span and rise is different, and you have completely different parabolas, these two are different parabolas, right? So now if you write 0 comma 0 at this crown, which is a common point for both the parabolas, so we are going to use this which is already discussed. So substituting for portion AC properties, geometry L1, span and rise, x and y coordinates of this point. Similarly for the portion BC, and we have these two equations. Then adding these two, we will have this L1 plus L2 by root H1 plus root H2. So now by equating this constant, which is again a constant, so which is equal to, so this is a constant, again you are equating to a constant, so that is L1 by root H1 is equal to this. So where L1 plus L2 is L, and this root H1 goes to the numerator, and the L1 value you can get it from this equation. Similarly, you can equate this to B also, because this is a constant, again this is also a constant. So equating these sides, and these two will be equated. So L2 will be L root H2 by root H1 plus root H2. So what do you know? The data is, you know the span of the arch, complete arch is L, and you may be knowing the H1 value, you may be knowing H2 value. Okay, so from basic survey of the arch, so from the crown point, what will be the level of springing point, because you are going to decide where your abutment should be rested on, foundation of the abutment. So this will be known to you, and crown point is estimated by the high flood level of the river, so that also is a known point, and another abutment foundation where you are going to rest. So these three elevations you will know, hence you know H1 and H2. So that way, if you are able to get L1 and L2, then each and every point on this portion uh, can be related with x and y coordinates with this portion, likewise this one. So the governing equation can be easily employed if you know H1 L1 value. Similarly H2 L2 value, where the H1 and H2 are the known values, wherein L1 L2s are unknown values, because only L is known, the width of the river, something like that, any abstraction, and the basic survey will give you all these levels. Okay, so this is about the arch having springing points at different level. Then going for uh, internal forces in the arch uh, are related to uh, the vertical and horizontal components. So in the other way, I can say that the horizontal and vertical reactions that you are able to estimate from the analysis must be converted to normal and radial components. This normal component, radial components, so that they are of use, and these h and v are of no use to you even though you know the values, because see, so this is the arch, part of the arch, let us say part of the arch, where this is a section drawn across the arch. So this is a normal thrust acting at this point. This is a normal thrust acting at this point. Okay, and this H value you get it from the equilibrium of the arch, and also the vertical force, sum of all forces, vertical forces to the left, sum of all horizontal forces to the left, all these you will get it. So these two values are known to you, and our intention is, say for example, if you want to estimate compressive stress in the arch, right, this is the arch portion, part of the arch selected. So where if you want compressive stress sigma, what we need to do is force by cross sectional area. What is this force? Normal to the cross section. This is the section taken. Okay, so which means something like this is a cross section. So what you need is normal force, not the vertical or horizontal force. So these forces are of no use to calculate stress in the arch. Okay, so compressive stress, if you want to estimate, you need normal thrust. So how do you find this n value, and even the shear stress if you want, the radial component, I mean to say the tangential component of the force. So you need q value. So how do you estimate this and this? By knowing h and v. These are the relations. Okay. So how do you estimate n? Simple, just take the components. Considering this as theta, the angle made by subtending angle made by the normal component with respect to horizontal. Similarly, this is going to be theta. So let's see what is n. So this you can have two components for h, and also v also can be uh, written into two components. For example, h, if you split into two components, so this will be h cos theta. This will be go for h n, let us say, component, and similarly this is h q component. So these are the two components for h. Similarly, you can draw for this, is because the arrow is downward, so the outward arrows will come. So v in the direction of n. Similarly, says v in the direction of q. So now the forces acting in this direction are these two. Okay, so that's why this is what h cos theta is this one, and this is v sin theta, right? Because this is theta, the opposite component is sin theta, the adjacent component is cos theta. So h cos theta and v sin theta, right? I'll go with the pointer. There's a pointer, right? So h is divided into two components, and also v is divided into two components, two rectangular components. So if you want to know what is n value, so these are the two forces acting. Now we don't have these two forces, we have split into four forces. Out of four, two are acting in this direction, two are acting in this direction. So the forces acting in this direction will contribute to n, that is Vn plus Hn, normal component of H and normal component of V. So what are those values? H cos theta is this one and V sin theta is this one. So this is how we get this relation. Similarly Q, if you see, so the direction that V is having is this one. So VQ, that means V cos theta is positive. Let us say this direction is positive. So V cos theta is positive, whereas this is opposite force, that's why it is written minus. H opposite component. This is the adjacent component and this is opposite component. This H sin theta. So V cos theta minus H sin theta is the uh, radial component or tangential component, what we call. So these two components are of use to find the normal stress and the shear stress in the arch. This is how we get the normal thrust and radial shear values from the estimated horizontal and vertical reactions at a particular location of the arch. Okay, so this is for now. Thank you.